Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about equivalent law, which is the 14th law, okay? We've talked about several laws, so please make sure you go back and have a look. In this case, we're going to play around with different formats of the equivalent law, and I will try to solve some questions. Before I proceed, don't forget to like, share, or subscribe, and click the notification bell so that when I post new videos, you'll be the first person to know. Now, the equivalent law, basically, we're talking about when they have the equal to sign on both sides, okay? And how do you solve such questions, all right? So I'm going to give you like 4 different formats that you need to keep in mind. This law is one of the most important law you need while solving questions, all right? So let's start. So the first one is if we have log of m to base a is equal to log of n to base a. Are you seeing it? Now on both sides, we have log a, log a. What we are now saying, for this to be equal, m must be equal to n. So what we say is that if you have something like this, so you can cancel them out, then you have m will be equal to n. So for example, if we have log 3x is equal to log 5 to base 3. What we are saying is that if they have the same base, okay, then this can cancel out. Are you seeing it? X will be equal to what? 5. Please, all right, if you have something like log 3x is equal to log 3, 5 plus log 3, let's say, let's put 7 here, okay? Something like that. You can't just cancel, okay? You can't cancel this like this. This is wrong. You only have to have one log on both sides. So that means in this case, for instance, what you have to do, we have to apply the product law here first, okay? Then we're going to have log 3x is equal to the product law. Please go back and have a look. So because they have the same base and it's plus, you multiply, and that'll be 5 times what? 7. Then that'll give us log 3x is equal to log 335. Then this can cancel that now, all right? It must only be 1 on both sides, and x will be equal to what? 35. Also, another thing to note is that you cannot also apply this law, for instance, when we have 2 log 3x is equal to log 3, let's say log 37, for instance. Now, because there's a number here, you can't just come and say you want to cancel it like this, like this. This is wrong. Before you cancel, there should be no coefficients in front of the log. So in order for us to remove this now, okay, and apply the rule, this 2, we can bring it back here, okay? The power rule, please go and have a look at it. The previous video, we talked about this already. And that will now give us log 3x squared is equal to log 37. Now we can then what? Cancel that out. So x squared will be equal to 7. So therefore x is going to be square root of what? 7. And it's going to be equal to the positive square root of 7 because it cannot have minus. So because remember I told you, when you solve square root sign, square root is equal to plus or minus, right? But so that means the answer is plus root 7 or minus root 7. So minus, you can't have minus as an answer in log, so you reject this one. Okay, you can have minus, so your only answer for this question will be plus root 7. Okay, so the same thing. So when you're doing the equivalent law, that's the first one, the A part we just talked about, all right? When you're doing this, make sure you don't have any coefficients in front of you here. And also you can only do this when you have only one logs on both sides. So let's go to the next one, the B, okay? B part. So the next law for this is that similarly, if ln m is equal to ln n. So like you know, ln is the same thing as log to base e, all right? So you can write this as, or you can write this as log em is equal to log en. So log e is the same thing as ln, all right? So what we are saying in this case as well, you can cancel out, then m is going to be equal to n. Similarly, like the last one, you can't cancel out when you have something like ln m is you can't cancel out when you have something like ln x is equal to ln 5 plus ln 3. You can now come around and say, oh, Mr. Terry says something like this and you want to now cancel this like this. You can't do that. So the first thing you have to do here is that you have to have one ln on both sides. So you have to combine this ln. We have to apply the product law or division law, depending the question. Like in this case, it's going to be product law. So it's going to be ln 5 times 3. Then you have ln x is going to give you ln what? 15. Then you can now what? Cancel that out. And x is going to be equal to what? 15. All right? The same thing I said. You can have 2 ln x to be equal to ln, let's say ln 5 or something. Okay? Or ln 4. So to make it easy, you can't cancel it out as well. You can't cancel this ln and this ln. Nope. It's not allowed. So the first thing you have to do is that you have to make sure, if you look at the law, there is nothing in front of the ln. So we have to take this 2 back here. All right? So we're going to have ln x squared. So please make sure you look at my previous laws. Will be equal to ln what? 4. Now you can now what? Cancel that out. So x squared will be equal to 4. And x is going to be equal to take the square root of both sides to cancel out this. Square root of 4, which is plus or minus. So x is equal to plus square root of 4 or minus square root of what? 4. So that means we have, you're going to have either 2 or minus 2. Like I said, you can't have negative. So you cancel this one. So the only answer you're going to have here is what? 2. All right. So that is that. So let's pick, let's say we want to, similar to what I talked about the last time. You can also, I've talked about this. So which other one? When you also have it on both sides. So if you have ln 5, it's equal to ln x. So you can see we only have no coefficient in both in front of ln. So we can then cancel this. So therefore, x is equal to 5. All right. So that is how you apply this one. All right, good. Now the third one we're going to talk about for equivalent law is that if a raised to the power x is equal to a raised to the power y, no, let's say it's equal to b raised to the power y. All right, now you can see, unlike the previous one, the previous ones that we've been talking about before, here we're having different index now. Now, how do you, and you are told now to make x subject of the formula, all right? Now the law, to remove this, you have to take law to base a of both sides. So we have a raised to the power x log, put it this way. So I'll take log a to both sides. So I want to make x subject of the formula in this question. So it's going to be a raised to the power x will be equal to take the log what? The a of both sides. So you can only do this when you're having both sides. So I want to remove this a. And how you remove the a is by taking log to base a. Because we know the rule that when you have this, you bring x back. We have x log a will be equal to y log b to base a. So log a is going to be equal to 1, and x is going to be equal to y log b to base a. Okay, so you can see, if, for instance, you are told to remove b, all right, you want to make y subject of the formula, exactly the same thing you would do. So in this case now, if you want to make y, instead of that, you take log to base b of both sides. So it's going to become log to base b, a raised to the power x, will be equal to log to base b, b raised to the power what? Y. You bring down the x, so x log a to base b will be equal to y log b to base b. B to base b will give you 1, so it'll give you y will become x log a to base b, and that will be the answer for that. So therefore, y is equal to x log a to base b, and that will be the answer for that. Okay, so the rule basically in this equivalent law is that in order to remove any of the index, you take the log to that index. Does that make sense? So if I want to remove a to make x, I'll take log to this. If I want to remove this, I'm going to take log to that. Okay, and you have to know that very well. So like I said, similarly, if there, remember, before you can do this, there should be no number in front of this. Okay, there should be no number in front of this before you can apply this principle. All right, so if for instance you have let's say you have 3x is equal to 5 raised to the power y or something, or 5. So to remove this 3, are you seeing it? What you then do, you take log to 3 to base 3 of both sides. Are you seeing it? You bring down the x, so it will be x log 3 is equal to log 5 to base 3. Log 3 is equal to 1. So therefore, x is going to give you log 5 to base 3. Are you seeing it? Now, also, if you're having something like 3, let's say, let's make 3x is equal to 5. But in this case, instead of just having 3, maybe you're having a, all right? Or you are having 4 multiplied by 8. Let's say we have 4 multiplied by 3 raised to the power x. You can't just take log 3 of both sides here because there should be nothing in front of what? The index you want to take the log. So here you have to then divide both sides by 4 first. Then you're going to have 3x is equal to 5 divided by 4. Now there is nothing in front of it. So regardless what you have there, if you have an alphabet, a variable, anything, you have to make sure that there's nothing there first. Then you then take log to base 3 now of what? Both sides. And this is now going to give you x log 3 is equal to log 3 5 over 4. Then x is going to give you log 3 5 over 4, and that will be the answer for that. Okay, so when you're solving this, please make sure that there is no coefficient or no variable in front of what? The index you want to solve. All right, so the same thing, similarly, if it's lean as well, we have, let's say we're having a raised to the power x is equal to b raised to the power y, okay? You can also take lean of both sides, but the only problem is that if you take lean of both sides, is you're gonna have so you're gonna have lean b raised to the power y. All right, so if you want to make x, so it's gonna become x lean a. You bring down the x here, will be equal to y lean what? B. So you can take lean as well. Then you divide both sides by lean a. If you're making the x subject of the formula, and that will give you y lean b divided by what? Lean a. And that will be the answer for that. Are you seeing it? Or if you want to make the y subject of the formula and you want to use lean, the same principle, you take the lean of both sides. So it's going to be lean ax is going to be equal to lean b to the power y. You bring x down, lean x lean a will be equal to y lean what? B. You divide both sides by what? Lean b in this case. You divide both sides by lean b. So therefore, y is going to be equal to, because this is going to cancel out, just the same way this canceled out here. So y is going to be equal x lean a divided by what? Lean b. So you can see, so you can also use lean to solve it. So if, for instance, we want to solve the same question, 3 raised by x is equal to 5, okay? 3 raised by x is equal to 5, for example. I can take the lean of what? The lean of both sides. Okay, so taking log, I can take the lean of both sides. So lean 3x is going to give me lean 5. I bring down x, so x, we're going to have x lean 3 is equal to what? Lean what? 5. I'll divide both sides by lean 3. So therefore, x is going to be what? Lean 5 divided by what? Lean what? 3. So you can see you can use different methods here to solve it. All right, so the same thing, the other example we had here. Similarly, if you had 4 multiplied by, or let me put multiply in this form. So 4 multiplied by 3 raised by x is equal to 5. Like I said, there must be nothing in front of it before you take the lean. Okay? So you can divide both sides by what? 4. So you can now have 3x is equal to 5 over 4. Then you can now take the lean of both sides. So you're going to have lean 3x is equal to lean 5 over 4. Bring down the x. You have x lean 3 is equal to lean 5 over what? 4. Divide both sides by lean 3. Divide both sides by lean 3. This will cancel that. So x will be equal to lean 5 over 4 divided by what? Lean 3. So you can see you can solve it using different methods. All right. So those are the 4 things you need to keep in mind for the equivalent laws, all right, that you need to keep in mind while solving. You need to keep this in mind. So let's pick some examples now, all right? So let's pick some examples. So let's assume we have log ax is equal to log a4, and you are told to find x. Easy, because you're hardly having logs to the same base on both sides, so this can cancel out. So therefore, x is going to be equal to what? 4. All right, so this can cancel out there, and x will be equal to 4. Number 2, we have lean 5 is equal to lean what? X. Because it's just lean on both sides, this can cancel out. So therefore, x will be equal to what? 5. Easy and straight to the point. The next one we have log of 3 over 4 to base a is equal to log of what? N to base a. Because it's the same, you can just cancel out. Therefore, n is going to be equal to what? 3 over 4. Easy, right? But what about if, let's take it up a notch. So we have 7x is equal to 3. And you were told to find x. So you can either use log or lean to solve this. So if you want to use lean, so we can still take the lean of both sides. You bring down x, so we're going to give you x lean 7 is equal to what? Lean 3. Divide both sides by what? Lean 7, because you are looking for what? X. And x is going to give you what? Lean 3 over what? Lean what? 7. If, for instance, you don't like lean, you can take logs. So you can take the log to cancel out the 7. You can take the log to base 7 of both sides. So it's going to become log to base 7, 7 raised to the power x is equal to log to base 7, 3. Are you seeing it? Then you bring down x. So x log what? 7 to base 7 is equal to log 3 to base 7. All this will be equal to 1. When the same base are equal, when the base is equal to the logarithm, is equal to 1, please. We talked about that law before. So x will now be equal to log 7, log 3 to base 7. And that will be the answer for that. So this and this, when you press your calculator, you will see that they both give you the same answer. All right, so that is that for that, okay? So please go to the worksheet, the textbook, and try and practice more questions, and you will be fine, all right? So let's try have a quick look at the laws again. So the first one is if you have logarithm on both sides, okay? on both sides of the equal to sign, one on the left, one on the right, okay, then you can cancel out, all right? If you have more than one or two on both sides, you have to make sure you compress it or you combine it using the relevant laws, product law, division law, any power law or any law, okay? And make sure that you have one on both sides. That's also applied to lien as well. Then also, if you want to get rid of an index here, okay, you can either take the log to that base, okay, to cancel it out, or you can also use the lien as well, okay? The lien is not going to cancel out, it's going to help you to get the unknown variable, okay? But if you want to cancel out a base, okay, you have to take the log of what? Both sides to that base, all right? And we saw some example, and that is that for that. So the next video we're going to talk about how to differentiate logarithms, okay? It's called the derivative of logarithm law, law 15. All right, so don't forget to click the notification bell so that when I post this video, the next video on the derivative of logarithm, you'll be the first person to know. All right, so please, if you have any question, don't hesitate to contact me. All right, send me an email and I'll get back to you. All right, so see you soon.